This lesson is about the methods for registration of ionizing radiation. When determining the individual dose of a worker, its possible difference from the true dose of an individual's exposure is ignored, due to the difference between the characteristics of the standard worker and the following personal characteristics of the individual: anthropometric characteristics of the body, individual organs and tissues, characteristics of physiological indicators, parameters of biokinetic of chemical elements in organs and tissues. The value of an individual dose is attributed to an individual basis of the results of dosimetry control. For the dosimetry control of professional internal exposure, use group dosimetry control of exposure, individual dosimetry control of exposure. Group dosimetry control consists in determining the value of the personal based on the result of the systematic measurements of volumetric activity in the area of working rooms, taking into account the time spent by personnel in this room, and carrying out the group dosimetry control is one of the elements of monitoring the radiation situation at workplaces. It is used for planning the dosimetry control of internal exposure of personnel to assess the individual radiation dose of personnel. Individual dosimetry control consists in determining the value of internal exposure of personnel based on the results of systematic individual measurements of physical quantities characterizing the internal exposure of an employee using instrumental methods. Individual measurements of physical quantities characterizing the internal exposure of a worker consist in determining the activity of radionuclides in the whole human body or in its individual organs, in human secretions or other samples of biological origin. Individual dosimetry control is used to determine the radiation doses of personnel of group A under normal operating conditions of the radiation source, if according to the available data, the value of the annual radiation dose at the workplace is, or according to the forecast, may be significant, that is, exceeds. To determine the radiation doses of all persons working with radiation sources under the conditions of planned increasing or potential dangerous exposure. The basis for detecting any type of radiation is its interaction with the substance of the detector. One of the main characteristics of the detector is the radiation detection efficiency, which is determined from the next ratio. The second part of the recording system is a measuring complex, the purpose of which is to convert the signal coming from the detector to a form that drives the recording device, such as pointer device, digital display, recording, mechanical counter, etc. Ionizing chambers are subdivided according to the following main features, such as principles of operation or current pools. Constructive design includes flat, cylindrical, spherical, and purpose includes registration of alpha, beta, and gamma radiation, etc. Ionizing detectors, which use the principles of gas amplification, are called gas chat counters. Geiger-Müller counters operated in a self-discharge mode in which the gas gain is great that the total current pulse does not depend on the primary ionization, but it is determined only by the properties of the gas filling the matter and the voltage across the matter. The physical basis of the scintillation method is the excitation and ionization of atoms and molecules of substance. Scintillation dosimeters are presented in this work by devices of different generations. By luminescent methods, we mean methods based only on radio photoluminescence and radio thermoluminescence. The effect of ionizing radiation on a photographic emulsion produces an effect similar to the effect of visible light. Chemical dosimetry methods are methods for determining and controlling observed doses of ionizing radiation based on chemical reactions. All methods are based on the irreversibility of chemical processes caused by ionizing radiation. Dosimeters are used to measure the absolute dose or the absolute dose rate of ionizing radiation. There are the following types of dosimeters, such as DRG Z01. This includes measuring the average observed dose of continuous and pulsed photon radiation. DRG Z02 for measuring the absolute dose of photon radiation. DRG Z03 is the same as DRG Z02. And DRG Z04 for measuring the observed dose of continuous and pulsed photon radiation and the maximum observed dose in tissue of continuous and pulsed high energy Bremsstrahlung lung photon radiation and etc. Includes also DRG 01T for measuring the absolute dose rate of photon radiation at workplaces in adjustment rooms and on the territory of institution using sources of ionizing radiation. Radiometers are used to measure the flux density of ionizing radiation, the activity of radionuclides. The radiation monitoring system should ensure the solution of the following tasks: determination of the size of the zones of radioactive contamination of environmental objects around the sources, determination of the levels of radioactivity of those objects of the environment from environmental pollution, from the pollution of which the entry of radioactive substance into the human body directly depends, detection of accidental, unforeseen or emergency environmental pollution, assessment of the effectiveness of means and methods for cleaning radioactive emissions and waste. The task of scheduled, it is the periodic monitoring, is dynamic monitoring of the amount and composition of organized emissions of the radiation situation in the areas where permanent sources of radioactive air pollution, territories and water bodies are located. It is carried out according to a standard plan in which the size of controlled areas, environmental object subject to control, volumes, the frequency of studies are preliminarily determined. With this control, observations are made of the amount of emissions, the concentration of radioactive aerosols in the atmospheric air, the intensity of radioactive well-outs at various distance from sources, radioactive contamination of the soil, the content of radioactive substance in the water of open reservoirs and water supply sources, the level of radioactivity of agricultural products in places of possible soil contamination. The task of operational control is to obtain urgent information about changes in the radiation situation. One of the priority areas of the scheduled periodic control is the control over radioactive emissions into the atmosphere. It is recommended to determine the amount of organized radioactive releases for each facility of the enterprises 2 times a year in winter and summer periods. Dispersed substance can form suspensions and true solutions not only in a liquid but also in a gaseous medium. Suspensions of solid and liquid particles and gases are called salts, and in air, aerosols. AFA aerosol filters are standard filters that are widely used for highly efficient collection of aerosols of various chemical and dispersed composition. Subsequently, the sample taken for the filter is processed under laboratory conditions according to approved procedures. The types of standard AFA filters produced according are designed by later observation and are listed below. In this slide, you can see samples of AFA filters. And AFA analytic aerosol filters are used for capturing and determining the concentration of aerosols in the gas environment, when determining the dust content in the air of the working area, when they determine gas dust content by external filtration, and determine the volumetric activity of aerosols by radiographic methods of analysis. In this table, you can see some of specification of AFA filters AFA filters are available in several sizes, making in the name of the filter 3, 10, 20, or 40 means the area of the filtering surface of the filter in cube centimeters. The types of filters are shown in the table. It is recommended to monitor the content of radioactive aerosols in atmospheric air at least once a year in summer. The levels of contamination of surface with radioactive substance are controlled in two ways: by directed measurements using radiometric instruments, such as RUP1 SZB2 1EM, and etc., and removing smears from contaminated surface with their subsequent radiometric examination. The degree of radioactive contamination of the soil is estimated by comparing the average value with the natural background of radioactivity in the soil in the given area. The level of radioactivity of agricultural products is monitored according to indications, and only in those cases when there is reasons to expect radioactive contamination of garden and horticultural crops grown in areas allocated on the territory of the sanitary protection zone. The level of radioactivity of bottom sediments and aquatic organisms is monitored by indication, for example, when deciding on the use of reservoir for swimming, fishing, and etc. Operation control over the state of radioactive contamination of territories is carried out of measuring the gamma radiation of the soil. According to the operational gamma control, the territory measures are being taken to eliminate foci of accidental radioactive contamination in the area of the enterprise. The obtained data, in comparison with the results of scheduled periodic control, make it possible to assess how much the range of propagation of organized radioactive releases or dust formation from the surface of unorganic organized sources has changed. Rational, repellent, and well-organized radiation control in the areas where uranium mining and processing enterprises are located is the most important measures for the sanitary protection of the environment from radioactive contamination. This lesson is over. Thank you for your attention.